Hi everyone. Thanks for coming out. This is a packed house. Thank you so much for coming out to my talk, and really appreciate the organizers, Sergey, for allowing me to come here a third year in a row. I love Barcelona. Happy to be back. My name is Grandja. I'm on the Spring Security team, mainly focused on the new OAuth support that we're building in Spring Security 5, OAuth, OpenID Connect, Jose framework support, and so forth. It's been like about 3 years now, or 2.5 years, that we've undertaken this rewrite of the new OAuth support in Spring Security 5. And as probably most of you are aware, there's an existing project, Spring Security OAuth. We call it Legacy OAuth right now. It's in maintenance mode. It's been around for about 7 years. It's going to eventually retire. That's why we're doing this rewrite. 5.2 is coming out in August, and at that point we're going to be at feature parity with client and resource server, so it's going to be a huge milestone for us. And we're hoping everyone's going to migrate to the new stuff, and we're going to provide a migration path and everything. So today I'm going to be talking about that, and the implementations within Spring Security 5 and 5.1 of the security standards that we've implemented. So, and I'm going to be demonstrating, I got a couple of slides here. I got a demo, and instead of doing a simple demo, OAuth 2 login or setting up a resource server, I get a lot of questions. How do you piece everything together, right? Where you have a lot of different components, like let's say a microservices architecture, you got multiple services. How do you communicate between each of the services? What token do you obtain? What authorization grant do you obtain to call this one service, and so forth? So how do you piece it all together? So that's what I'm going to be going through, a more advanced sample with 3 microservices. That's going to be on the next slide, but I'm going to give a really high level of the standards that we've implemented so far in Spring Security 5, up to 5.1 and 5.2. Let me just get a raise of hands. I want to understand who's very familiar with OAuth here. Okay, perfect. Who's used the Spring Security support 5.1, 5.2, OAuth 2 logins, resource server? Who's using the legacy OAuth? Okay, that's good. They'll be easy to use the new stuff. So I'll just give a really quick high-level overview, and then we'll just jump into the demo and putting it together. OAuth 2 authorization framework. This is all about authorization. It's all about authorizing a third-party application, an OAuth client, an OAuth application, whatever you want to call it. Authorize it to access your protected resources, right? Your typical use case is log in with Google, log in with Okta, right? That's your typical use case, the one you guys all know, right? And girls. And you go to a website, you click on log in with Google, and you get redirected to Google. You log in, and then you get this consent screen. Do you authorize this OAuth application to access your protected resources, specifically your user info, your email address, and so forth? You click on authorize. You've just authorized this client. In the background, the client gets this authorization code or an authorization grant, typically an authorization code, if it's the authorization code grant, that is. And it exchanges for an access token, a short-lived credential that has the capabilities to access your user profile information, right? So all about authorization, OAuth 2 authorization framework. It only deals with authorization. OpenID Connect, that's where authentication comes in. It's built on top of OAuth 2, and leverages the grant types, the authorization code, but it introduces the ID token, right? Instead of an authorization request, it's an authentication request, right? But it leverages the authorization code, but when it hits the token endpoint on top of the access token, it also gets this ID token, right? And this ID token has a set of claims in there that describe the authenticated user at the provider: first name, last name, subject, issuer, and so forth. And we're going to take a look at that as we go through the demo. OpenID Connect discovery. OpenID Connect providers may implement this endpoint where clients or resource servers can discover provider metadata. For example, discover the authorization endpoint, token endpoint, user info endpoint, etc. So I'm gonna show you an example of that as we're going through the demo. JWT, self-contained type of access token. You got also opaque tokens. JWT, I mean self-contained. All the attributes are in the JWK set. So it's pretty convenient for resource servers to receive a JWT, decode it, and make an authorization decision. Opaque tokens, on the other hand, and that's coming out in 5.2, by the way, opaque token support. It's opaque. You can't deduce anything out of it. It's a unique identifier, and the only way the resource server can get attributes associated to that access token, it has to call the introspection endpoint. So it's an extra request response call. Obviously, it reduces scalability in that respect, but at the same time, there's pros and cons to self-contained token and opaque token. I'm not going to get into all that right now, but there you go, JWT. And then JWS, I mean, JWTs can be signed. An ID token is signed, and hopefully every JWT is signed at the very minimum. You definitely do not want to be using unsecured JWTs for sure. So that's JWS. And then you got JWE, Java Web, JSON Web Encryption, which is part of the whole Jose framework, which is JSON object signing and encryption, right? And then we have the JWK, JSON Web Key. So that's a JSON representation of a public key or a key, right? It could be a symmetric key, like a shared key, or asymmetric key, like an RSA key, that's ultimately used by the provider to sign the JWT, and the resource server or the client in the OpenID Connect side of things needs that key to verify the signature, right? So there's from a very, very high level, the standards that have been implemented in Spring Security 5, and I'm going to show you how we're leveraging this in this app, right? And from a high level, I'm just going to go over, this is what we're going to do, and there's a lot to do, and I'm going to try to get this in without rushing, and kind of having a whirlwind of a demo. I'm going to do my best to really pace it, but get all of this done, because this is our goal. This is the architecture. We got 3 microservices, we got a UI app, and then the authorization server. The UI app, right, acts as an API gateway or a backend for front end, that pattern, if you know that. All requests funnel through the UI app. The client is a browser or a native mobile app, whatever, right? But all the requests go through there, provides a coarse-grained API, and ultimately it aggregates or calls the microservices, the finer-grained APIs, and aggregates the response back to the client, right? So the UI app here, basic thime leaf application. This is perfect spot to set up OpenID Connect authentication. This is where cross-cutting concerns can happen. You can even set up authorization here, routing, whatever. But the API gateway pattern, it's a well-known pattern, best practice for sure. Then we got these 3 microservices, right? So the UI app is going to call microservice A, microservice B. So we're also going to set up an OAuth client there as a second step that's going to ultimately go through the authorization code grant flow to get an access token, then pass it to microservice A, microservice B. Microservice B, we're going to set up an OAuth client there with the client credentials grant, and I'm going to explain in what cases do you use client credentials grant compared to authorization code when we get to that. But we're going to set that up there, and then it's going to call microservice C. So that's what we're going to do. So we'll just get to it right now. So let's jump to the demo here. I'm just going to show you actually. So this sample app, I got a few different flows here. The whole goal, my whole goal anyways, of this app is to demonstrate flows, right? And best practices, as far as patterns go. Here I got 5 different flows. I got very simple flows there. Then I got a token relay pattern, token exchange. I can't demonstrate all of that. We're just going to focus on the bottom on the client credentials flow. But the whole goal of this app is to have something more advanced, right? A more advanced architecture that has security implemented as far as Spring Security 5's OAuth and OpenID Connect support. So people could go to this, check it out, learn from it, and just learn best practices, right? And I don't have a domain model built into this because domain model is just going to be noise, right? This is all about interactions between services and what access tokens flow between each services. So I'm literally displaying like if I click on this flow, as you can see, there's a flow sequence there, and then I got some metadata, right, between each of the interactions between the components. UI app call service A. There's no data there now, but this is going to get populated as we're, securing the application, right? But you've got a JTI there. That's basically the JSON identifier, so we'll see what access token is being passed, authority, so maybe authority-like information like scopes and so forth. So let's get to it. Let's do our first part of the demo is we're going to set up OpenID authentication with the UI app. What does that take? Now the first thing we got to do, these are all Spring Boot apps. So the first thing we got to do is add the dependencies, right? I'm going to make this a little bit bigger so everyone can see. So the two dependencies required for OAuth Client is obviously the Spring Boot starter, security starter, and the OAuth Client starter. Those are the two starters done, right? So add those first. And then the second thing, now I'm going to actually remove, I've actually disabled security. As you saw, I went into the application, I didn't authenticate, and I just got in, right? So I've disabled everything by excluding the auto configuration for boot. So I'm going to remove that right now. And now we're going to go into the application properties, and we're going to add the properties for the client. I'm going to go over these a bit. The key properties here, so Spring Security OAuth Client, that's the base property path. Right below that we have registration and at that level and provider. So registration is you could register more than one client, right? Because you could use a client, like this client here is used for my OpenID Connect authentication, right? I could use another client for the authorization code, which I'm going to demonstrate as we progress. But I could add as many clients as I want, depending what this app needs, right? And then provider is the provider metadata. Obviously, I got to know the authorization endpoint, token endpoint, user info endpoint. So I could set up multiple providers. So technically, I could set up anything here. I could set up Google, Okta, UAA, have multiple clients, and so forth, right? Now, right below the registration, this is the registration ID. It's just a logical name. I could have given it any name whatsoever. It's just got to be unique within the client registration repository. But the key thing here I wanted to point out is the scope, OpenID. That's a required scope for OpenID Connect. That's what triggers an authentication request. If I removed OpenID, even though it's using authorization code, it just falls back to the authorization code grant, standard OAuth 2. So OpenID is the indicator this is an authentication request. So you got to make sure you add that for OpenID Connect. And then the redirect URI, this is the default redirect URI where when I log in, I authorize the client to access my user information, and then the authorization server redirects the authorization grant, in this case it's the authorization code, back to the redirect URI, back to the application. Client receives it, exchanges for an access token, right? And then we have the provider information, right? Authorization, token, user info, and so forth. So that's it. So that's what I did, right? I basically added my dependencies, added my properties. Now let's see what happens. I'm going to restart the application, and then we're going to see what happens here. Okay, this is good, right? So we got redirected back to our authorization server, which I'm actually using UAA for my authorization server. For those of you who don't know, UAA is Cloud Foundry's identity management system. So I'm using that, running that locally. So I get this message here, typical message that you get if you're logging in with Google or whatever, do you authorize Google or do you authorize this application or this client to access my user information, email address, profile, and so forth. So I'm going to click on authorize. And there you go. So now I see extra information, right? I've authenticated, right? I got my name up at the top right there. I have this link that displays some information like I was talking about earlier. Excuse me. Like I was talking about earlier, the ID token comes back on the token endpoint on an OpenID Connect flow. And we have claims in the ID token. Here are the claims. Here are some of there's more claims, but these are some of the claims I'm just displaying here right now. Obviously, the two key ones are issuer and subject. So issuer, the unique identifier of the provider, and then subject, the unique identifier of me at the provider. And the combination of those two is basically a global unique identifier of a user at a provider. And then we have, a few different claims, my name, first name, last name, email, and so forth, authorized party, the audience, who's the audience of this ID token. Obviously, it's the client. And then I have some information here, as far as the clients that have been registered. I could look at the access token. I got the ID token. This information here, like I said, this app is more of a best practices and learning what happens between the flows and what's happening in the session, just viewing the information, seeing, just introspecting within the application, what's happening as far as, when security is enabled here with OAuth. So there you go. So I got OpenID Connect authentication implemented. That was pretty easy, right? I had my dependencies, I had my properties, and I'm done, right? Easy. Well, I find it easy anyways. Hopefully you do too. Now, I'm looking at this though, and there's a few properties here. I like to make this a little bit smaller, make it even easier, right? So what can I do? I could leverage OpenID Connect Discovery, all right? So OpenID Connect providers can implement this endpoint, and they expose provider metadata. So as you can see here, I got the authorization endpoint, token endpoint. I mean, there's quite a few things here that providers can expose. And basically clients or resource servers can call the discovery endpoint and ultimately use this data. For example, a client could look up the discovery endpoint and automatically configure itself with a few different of these pieces of information. So let's try that. Let's try the OpenID Connect Discovery integration with Spring Security and make our client registration even simpler. So what I'm going to do is I'm going to get rid of all this stuff, right, on the provider. I'm just going to add the issuer URI, and I already know by default these two are defaulted, the authorization code and redirect URI. So that's a lot easier, right? I mean, obviously you got to supply the issuer URI at the minimum. You got to supply the client credentials, and I'm adding the scope. So this is the minimal, absolute minimal configuration. Let's make sure this thing works. I'm going to restart this. Let's log back in. I'm going to close this just to make sure I show you that we're logging back in. There we go. So we're still working, right? Okay, so I'm logged in. Perfect, right? So that was it. So minimal configuration dependencies, OpenID Connect. There we go. Let's move on to the next thing. The next thing is, okay, so we set up authentication. Now we got these 3 microservices, unsecured microservices still, right? As you can see, so we got to secure them. So the first thing I'm going to do is we're going to work backwards. I'm going to secure the resource servers first, right? And then I'm going to hit this endpoint. The client's going to try to call. Obviously, it's not passing an access token. There'll be a 401. That's the expectation, right? So let's configure a resource server next. Let's configure. Now it's like any Spring Boot application, the first thing you do, add the dependencies, right? So let's do that first. We will work with microservice A, and the Spring Boot starter for make this a little bit bigger so everyone can see, is OAuth to resource server, right? And obviously you got to use add the security starter as well, right? So there you go, they have that. And now the next thing is properties again, right? Once again, I'm going to have to remove. I disabled the auto configuration, so I'm going to remove the auto configuration of my Spring Boot annotation. So that takes effect, and then we're going to go into the properties and configure our resource server. All right, so here we go. So here's our. I'm going to just actually close some of these windows so we could make this a little bit bigger. So here we go. So Spring Security OAuth to resource server. That's the base property path, JWT access token. You know, in 5.2 we're going to have opaque there, right? And then you can have your property settings under there. But this is for JWT support. And then I could set up the JWK set URI. Let's take a look at this. What is this? What's this JWK set URI? If I go to the browser here and type this in, here we go, right? So this is basically what I was talking about earlier. It's a JWK, JSON web key. It's a JSON representation of a key that the provider uses to sign tokens, right? In this case, as you can see, key type KTY, it's an RSA key, right? So it's a public key, and this is ultimately what the client or the resource server uses to get the public key and ultimately uses it to verify the signature, right? So there's and there could be more than one. It's rooted at keys, so it's an array of keys, but in this case we just got the one key, but there could be more than one. Now we'll go back here. Now we also support OpenID Connect's discovery on the resource server side. So instead of specifying the JWK set URI, I'm just going to specify the issue URI, and it's going to discover the JWK set URI just for the convenience, and I just prefer it that way. So let's do that. Now let's start that up, and let's make sure it's secured. We'll go to the service I'm just going to go directly to the service and just see what happens here. I think it's actually 9,000. Right, this is what I got, right? This is what I expect, 401, right, as you can see here. So that was pretty quick, right? Like literally dependencies, properties, and I'm secured, right? Secured as in, the default configuration is when an access token comes in, when a JWT comes in, it will decode the JWT, it'll fetch the JWK, right, and resolve the public key, and then it will verify the signature. And then the next thing it will do is it'll verify that it's not expired, and then it'll also validate the issuer, right? That's the default configuration. And then it's authenticated, right? That's the authorization rule. If you want to apply finer-grained authorization, as in scope-based authorization, which we are going to do at the end if we get to it, we definitely want to do that. But I'm just letting you know, right now, that's the default configuration. Okay? So let's just, what I'm going to do, I'm actually just going to, I'm not going to bother repeating this exercise for microservice B because ultimately it's the same thing, right? And we're just going to cut to the chase and just check out this specific commit, and we are going to see what happens when we try to access it through the app right now. So at this very point, I have microservice A and microservice B secured, right? Same steps for both, right? Let's try to access through the app. Let's see what happens. Let's make this a bit smaller. Okay, that's what I expected. I expected 401 because obviously we haven't set up the client to actually pass the access token, right? And so that's what we're going to do next. So right now on the UI app, we're going to set up a client that goes through the authorization code graph flow that obtains an access token that has the capabilities or the authorities to call microservice A and microservice B. So let's do that next. Same procedure, once again, is dependencies. Okay, our dependencies are there, right? Because we already added it. The next thing we're going to do is we are going to configure the OAuth client, the new OAuth client. We already have this existing one here. And we're going to configure an auth code one. And there you go. So I've given these really generic names: microservice A, microservice B, client ABC, authority A, authority B, right? Just it's so much easier to track and just generic. And really, the way I've named it is microservice A authorizes authority A. Microservice B authorizes authority B. So if you know, after this, if you take a look at it, that's how the naming came about. So in this case, client ABC, right, has the capabilities or the authorities for authority A, B, C. Therefore, it could access microservice A, microservice B, microservice C. Right, just for a little bit of info on the naming convention here. And that's it. Everything else is pretty standard from the previous. The authorization code grant is by default because we're discovering by the issuer, and we're just requesting those 3 scopes. So let's do. So that's the first step. Now we have the client. Now we have to use the client, right? So the next thing we're going to do is we're going to actually configure the web client integration. So we have support for web clients, and I'm going to show you when I get to this here. And I was going to make this a little bigger, so we'll talk about this a bit. So this is standard configuration for any web client that you're going to use in any service. This is pretty much like cut, copy, and paste. So we have this exchange filter function, servlet OAuth 2 authorized client exchange filter function. Super long name, right? But it makes sense, right? It is an exchange filter function, right? It requires an OAuth 2 authorized client, and this is the imperative version, the servlet version, right? We also have the reactive version, prefix with server, same name but server. Now, what does this do? I mean, an exchange filter function can tap into the request pre-processing, right, of a web client, and that's ultimately what we got to do, right? We got to put the access token as a bearer token in the authorization header. We got to tap into, before that request is sent, we got to add that header, right? So we're plugging in with an exchange filter function, and this specific exchange filter function needs an authorized client, right, to get the access token. What's an authorized client? Let's take a look at what an authorized client is. There we go. So an authorized client, really, it's an association class. Like when a client gets authorized by a resource owner, right, we have a client, right? The client registration, the principal name, that's the resource owner identifier. And then the result of that authorization is an access token and optionally a refresh token, right? So when a client goes through an authorization grant, the end result is an authorized client. And an authorized client is stored in an authorized client repository, right? So that's what an authorized client is. So the exchange filter function, it needs an authorized client because that's where it gets the access token. So we pass in the client registration repository, the authorized client repository, so it knows how to do its thing, right? And that's pretty much it. And then, so we create an instance of this, and then we apply it, as you see this one line here, we apply it to the builder. And ultimately what this does is it adds it as an exchange filter function. And it has quite a few different capabilities. I mean, a couple of them is if an access token is expired, it will refresh it, right? It will refresh it for an authorization code client if there's a refresh token. For a client credentials client, if the access token is expired, it will just call the token endpoint, ultimately renewing the access token, right? So these are the capabilities built into it. And this is ultimately where other grant types are going to be added. For 5.2, we're planning for resource owner password, and we're going to definitely try to get into JWT bearer grant as well. So this is the web client configuration. So now that I've configured my client, my web client, now I got to use this web client. So let's take a look at what does that take. I'm going to go to that main controller that gets called when I click that link, right? And I'm going to add, I mean, there's a few different ways. I'm going to show the annotation way of authorizing a client. So this annotation, this handler method argument resolver, registered OAuth 2 authorized client, right? I specify the registration ID client ABC, because that's what I've configured. That's the registration ID. That's the specific client that I want to resolve and ultimately use in a protected resource request. So this annotation, what it ultimately does is, I mean, it resolves an authorized client in a nutshell. But if the client is not authorized, then it triggers the authorization grant. So in this case, it's an authorization code grant, so it triggers that flow, right? And eventually, it gets redirected back to this endpoint, because this is the redirect URI, and then it's able to resolve it, because at that point, it's in the authorized client repository. Now I have my authorized client, therefore, I could get the access token, or the web client could get the access token. Now I got to use it, right? So the next thing I'm going to do is, I'm just passing null into here. I'm just going to add this into these methods, and we're going to go straight to the actual, where it's set. So right here, web clients, right? This is the main line. So web client has the capabilities of adding request attributes, which is very nice. REST template didn't have that, which was too bad. But either way, so what this is happening here, what's happening here is, this is the OAuth to authorized client static method returns a consumer that ultimately adds the authorized client into a request attribute. So when the exchange filter function is hit in the filter before the request is initiated, it knows where to find the authorized client, and therefore knows where to get the access token, and therefore it adds the header, right? So that's basically the next step you got to do for the web client integration. So basically, I think that's pretty much it. You got the web client configuration. You configure the web client configuration, which is standard, and then resolve it through the handler method argument resolver, and then use it in the web client. So based on this, we're going to start this. We're going to restart UI app now. And then we're going to there we go, right? So the handler method, the registered authorized client, like I mentioned, it triggers the authorization because it couldn't resolve the authorized client, redirecting back to the provider. As you can see, when I configured my client, I configured it to request these 3 scopes because I want to be able to call all 3 microservices. And there you see it. Do you allow access for all these 3 authorities? I'm going to click authorize. And there we go, right? So now we have information. As you can see here, UI app calls service A. I've highlighted specifically the JSON web token identifier. As you can see, it's the same one, right? The authorities. One thing to note here, you'll see the authorities there, scope _. So resource server by default will inspect the JWT and it'll look at this, try to find a scope claim, because it's optional. It's not necessarily there. But if it finds a scope claim, whether it's scope or SCP, then what it will do, it will basically append scope and then add those as granted authorities to the authentication instance, the JWT authentication instance, in case you're wondering what that scope prefix there is. And then the subject, that's me. I own the token, right? I authorize the client. The client's acting on my behalf to access my resources, but the audience is the client, right? So as you can see, we got some information here now, but we don't have any information with service B to service C. So that's our next step, and I'm just doing a time check, and I got about 15 minutes, so I'm going to try to expedite this. So the next thing we got to do, what I'm going to do next actually is, we didn't have microservice C secured, so I'm just going to check that out. So now at this very point, we have all 3 services secured, right? I'm just going to restart this. And now we're going to set up the client on microservice B to call microservice C, right? But this time we're going to use the client credentials grant. And why am I using the client credentials grant? Why am I not using the authorization code? Why am I not using maybe a token exchange pattern? I mean, in the end, you know, for the authorization code grant flow, there's a user, there's a resource owner authorizing a client. The user owns that token. There's user context information in that token. So you would use that grant in, I'll use an example, like an e-commerce site. You know, I got a shopping cart, right? I'm buying some products. Right? Obviously, there's user information attached to the shopping cart, attached to the order. But product, like an inventory service, user doesn't own that. You don't need user context information. That's a system service, right? So client credentials is a perfect candidate for that kind of a call. So imagine microservice B, imagine microservice C in inventory check service. That's when you would use a client credentials grant. You don't need user context information. It's a system service, right? So let's set that up right now. Let's set that client up. So we're going to go to, excuse me. Now we've already set up our dependencies, right? We got a resource server and client, so that's already done. And now the next thing is, I actually got to disable the auto configuration. So I'm going to go to that. Yeah, actually I already did that. Yeah, on the previous one. And now we're going to set up a new client. Okay, so here we have client C, client credentials. We're just going to request one authority. You know, all very similar. The only difference here really is the authorization grant and no redirect to URI, but everything else status quo. So I've set up my client. Now I got to use it. It's the same procedure. Now I'm going to go and set up my web client configuration. And let's go to our web client here. I'll remove this. Once again, like I said, the same configuration applies. Right, there we go. And now we got to use, right? We got to use the authorized client, and we're going to go to the handler or the controller. So let's go to microservice B service, which is right here. I'm just going to actually close these windows because things are getting a little bit busy. And then we're going to do the same thing. We're going to resolve. And this is client C, right? Because that's what I just configured, client C. You'll notice there the JWT authentication token. If you're not familiar, you could resolve the authentication and then you could have access to the JWT directly if you needed it, if you're not aware of that. So here we have the authorized client. I'm resolving it, and then I'm going to use it. All right, so same procedure really here as well. Like really, you know, compared to the client on the UI app and the client on microservice B, everything's really the same. The only difference is the client properties, right? The authorization grant, there's no redirect. Everything else same, right? Consistent, right? Now the only thing I wanted to point out though is if I go back to the application properties here. So we have a resource server acting as a client as well. And the default configuration for Spring Boot auto configuration, that is for OAuth Client functionality, it will enable OAuth 2 Login, OpenID Connect, and OAuth 2 Client, right? So I don't want that, right? I don't want to enable OpenID Connect. So I'm going to override Spring Boot's auto configuration. So I got to specify my own custom configuration. So let's do that. Okay, we'll add our resource server config. Extend that, and then we'll do our enable web security. And let's just get our template out here. And there we go, right? So we've enabled resource server. Here, I'm gonna make this a little bit bigger so everyone can see. So there's our custom configuration, which is pretty much exactly what Spring Boot would do as well, other than minus the OAuth 2 login. but this is exactly what Spring Boot would do. But we want to override it, remove OAuth to login because we don't want that, right? So there we go. Let's start up. Let's restart microservice B. And microservice C, I already did start, but I'll try it again just to be sure. And at this point, I should be able to see all three flows and all three pieces of data between the three interactions. Now let's take a look. And there we go, right? As you can see here, the JTI is different, right? Because we use the client credentials grant. And you can see that the authorities here, scope authority C, and the big difference here is the subject, right? Who's the owner of this access token? Well, it's the client. It's not me, right? Because I use the client credentials grant. This is a systems level service, the inventory service. The client owns the token. The client makes the call, right? So there we go. So that's pretty much it. That's like 3 microservices secured. You know, not fine-grained authorization. We're going to do that next because we actually got time, which is great. And we've set up OpenID Connect. So now we've completely secured our architecture, right? Now let's set up finer-grained authorization because ultimately, you know, microservice A should authorize only on access tokens that have scope A, right? Or scope authority A, and microservice B, scope authority B, and so forth. So let's set that up. What does that take? Let's just do it for one. We'll do it for microservice A. And we'll go to microservice A here. Actually, no, we'll do it on microservice B because I have a custom configuration there. Because we need to have a custom configuration, obviously, to set that up. So we'll go into resource server A. And I will remove this, and then we'll do this. All right, so service B. So here we have it, right? We're authorizing on anything service B and has authority, scope authority B. Now let's actually let's put X in there, right? And restart and see what happens. Because the expectation would be forbidden, right? Because the access token that's coming in here has authority A, authority B, authority C. It does not have authority X, right? So the resource server should not allow the request to go through. And let's just confirm that. All right, there we go. So we got 403 forbidden, right? That's the expectation, right? So we've set up fine-grained authorization. Now we're going to change this back to B, right? We will restart this. And we will ensure that things are still working. And they are. All right, there we go. Now, I encourage you to take a look at this sample and give me some feedback, because the whole goal of this sample is because I get a lot of questions, right? How do you piece everything together? I mean, it's easy to have one sample, a basic sample setting up OpenID Connect, or one resource server with one client. Big deal. This is not real world, right? So I want more of an advanced sample that's more real world, that demonstrates common patterns, right? You know, I have the token exchange pattern. Why would you use that pattern? I mean, look at this here, right? I have this token here getting passed with 3 scopes, right? Authority A, authority B, authority C, right? Why would I pass an access token to a resource server that doesn't authorize on a specific scope? Like, for example, microservice A is only concerned about authority A. It doesn't care about authority B, right? So ultimately, this access token has higher level of privileges, right? Which means if it gets leaked, then I have higher access, right? I could access all 3 services. Now, if I only had an access token that was, you know, that only had authority to access a specific service, the minimal privileges, for example, an access token that just had, well, just like the client credentials, right? The client credentials has one authority. That's a good one, right? Because if this gets leaked, well, you could only access the inventory service. That's it, right? If the other access token gets leaked, then obviously I could access more and do more damage, right? That's what I like about this token exchange pattern, and it's one of the flows in here. Obviously I can't get to it today, so I'll just talk about it. Is microservice B, right, will receive an access token with three scopes associated to it. Ideally, what I would like to do to keep security even tighter is exchange that token and downgrade the scopes. The access token or the JWT looks pretty much the same. The only difference is the scopes have been downgraded to only the scope that the destination resource server authorizes on. So I would use this token exchange pattern, which is one of them is a JWT bearer grant, which we're planning on getting into 5.2 to pass the access token that I received for another access token, exchange it for lesser scopes, right? And then call microservice C. And that's a good one, right? I like that one because you're keeping security tight, right? If that gets leaked, once again, you could only access that one service, right? And that's why the token relay pattern, that's the other flow that I have there, you got to be very careful with that one, especially, like, I know it's very convenient to set up a client that has, 5 scopes, 10 scopes, but when you do that, you have an access token that has a lot of power, right? And it's convenient, yes, and then you just relay it to all services because all of them, will take it instead of setting up clients within the services that, exchange it for more downgraded scopes. But you got to be very careful using token relay patterns. It's definitely a pattern I wouldn't recommend unless it's behind the firewall in tight security quarters and so forth. But even then, yeah, you just got to be careful. I just wanted to kind of really mention that from a high level. But feel free to check out those other 2 flows. And I made it just in time. I can't believe it. Thank you very much. There's a link to the repo there. So yeah, thank you.